All right, so everybody has these notes. It says Algebra 2, Chapter 1, Fundamentals of Algebra, has the cartoon on it.
Wait, is it this?
Not the other one.
What?
We're going
the
over
red
the
one.
It's the red one.
red one. Fantastic. All right, so first things first. 1, 1, the real number system. So I like to define things basically the way I would talk to my friends and not the way I would explain it to, let's say, my college professor, Dr. Gupta. Okay, so when I'm explaining these things, I am defining things the way they probably should be defined and not the way they are defined. So what is a set? Well, a set is a collection of numbers. If you don't like the word collection, you can write a group of numbers. It's just a group of numbers. Now, let's start at the bottom and let's get to the top, kind of like Drake's song. Start from the bottom, now we're here. So let's start from the bottom. What are natural numbers? Well, first off, natural numbers is way too long. I don't like writing natural numbers. So essentially, I'm going to use this symbol. Okay, it's kind of like an N. That stands for natural numbers. My board isn't aligned, but it's kind of like an N with 2 legs. Okay, so natural numbers, okay, they are easily kind of like defined as 1, 2, 3, 4, 5. You guys get the point? It's kind of like all of those. Now, what's the difference between natural numbers and whole numbers? Not a whole lot. Okay, whole numbers are kind of like a W with that. Okay, and the only difference is I add 0 in it. So these numbers basically are they're pretty big, but they're not that big. Okay, there's like an infinite number of those. Okay, but like natural numbers is smaller than whole numbers because 0 is in the whole numbers. All right, but what I'm getting at here is natural numbers and whole numbers. I can't do a whole lot with them. Okay. They're not like closed on all the operations, meaning like I can't really subtract with whole numbers and natural numbers. All right, so I can only really add on those. So like if I add 2 whole numbers, I'll get another whole number. But with integers I can add and subtract. And we all know integers. That's the fancy Z, okay? And integers are like -2, -1, 0, 1, 2, 3. Okay, they go on forever in kind of the both directions. They're positive and negative. So I can add and subtract on these, no problem. But as we all know, there are more than just 2 operations, okay? Mr. Woolley, what other operations do I have? I have addition, subtraction, and then there's some more.
Multiplication, division, or
Yeah, so I have multiplication and division. But the thing is I can multiply on the integers. I can multiply 2 integers and get another integer. But the real problem is I can't divide. So that gives me rational numbers. Rational numbers, okay, these are, no, sorry. These are a fancy Q. It's like a Q with an L in it. Okay? These are essentially decimals, fractions of positive and negative numbers. Nope, not negative. Sorry. So I have positive, negative, fractions, decimals, all of that fun stuff. Now, there's one big difference between irrational and rational. Does anybody know the difference? What about you, Ed? Do you know the difference between them? It's okay to say no.
No.
Okay, that's good. Julia, do you know the difference between rational and irrational? Okay. Franklin, what about you? Do you know the difference?
No, I don't remember.
That's okay. I'm completely cool with that. This stuff's new. Hannah,
Yeah.
do you
Can't
know the
rational be
difference?
like a ratio?
What's that?
Can't rational like be a ratio and like irrational can't?
I like what you're getting at. I don't love the word ratio, but it is acceptable. So what Hannah's saying is she's using this fancy word called ratio. I know it's not that long, but it is fancy. What Hannah's saying is rational numbers are fractions. I can write them all as a fraction, okay? Like 1.5, I could write it as 3/2. But irrational numbers, I can't write as a fraction. So Hannah, can you give me an example of a fraction, or of not a fraction, of a number that can't be written as a fraction? There's a big one, okay? I love to eat them around Thanksgiving. Do you know which one I'm talking
Pie.
about? What's that?
Pie.
Pie. I love pie. Favorite pie? Apple pie. Love apple pie. Pi is an example of a irrational number. Now we're going to go back to Cody. All right, it sounds like Cody's getting a text, okay? Because he probably doesn't have the sound off on his phone, because that would be a very Cody move.
That was not me.
It's okay, it will be at some point.
You
Cody.
think people text me?
What's up?
You think people text me?
No.
Yeah. So why would it be me?
Cody, here we go. Cody, you were talking about operations. So we have addition, subtraction, multiplication, division, and then there's this kind of like other thing. Do you know what I'm talking about in that other thing?
Nope.
All right, what if I told you, let's play a game. Trees have them. They're at the bottom of a tree. They kind of
Roots.
go underground.
Oh, square
Yeah,
roots.
square roots. So irrational numbers involve kind of like square roots. Now, the square root of 2 is kind of like a big one, but the square root of 4 wouldn't go here because we all know the square root of 4 is 2. So these would be irrational numbers like pi, the square root of 2, negative square root of 3, all right? And then there's another one you guys probably don't know, but you love it because it involves money. And we all know that Jake Stevens loves money, and that's E. E is used all the time with banking. It's like compound interest and continuous interest, and we love it because that means I get paid interest on all my money. All right, so the last thing is real numbers. Real numbers, okay, not a formal definition here. I'm just going to go with, at this point, and like I said, this is not a formal definition. It's any number you can think of. Now, of course, there is a set of numbers out there, okay? They're not real. And Hans would probably be like, they're fake, okay? No, they're not fake numbers. They're called imaginary numbers. And we'll talk about that later in the year. But at this stage in your life, any number you can think of is a real number. Okay, it's any number you could encounter in the world. All right? Now, I was talking about, at the start of this, All right, and I'll give you a second to make sure you guys copy this down. But at the start of this lesson, I was talking about the size of these individual sets of numbers. And that's the picture underneath it. So let me scroll up. All right, so this diagram right here is talking about the real number system. So any number you can think of would end up being in this box. And now the box is divided into kind of like two sections. They're really supposed to be like the same size, but they're not. But because I need more space on the left, this is going to be rational numbers. Meaning on this side, it's irrational numbers. So like all of those examples I gave you of rational numbers could go in that box. And since I did that up top, I'm not going to do it down bottom here. All right, so let's talk about the one right below rational numbers. And that was what? Integers? So integers is that one right there. Followed by whole and natural. All right, and why did I show you this diagram? Well, if something is a natural number, meaning it's inside that really small box, it's also considered a whole number, an integer, and a rational number. Meaning if I pick the number 3, I would describe it most specifically as a natural number, but it is also whole, an integer, and rational, and a real number. And this is going to be in your homework on WebAssign. All right? So you're going to have to classify numbers. And one of the examples that you have in your homework is kind of like this down here. So let's look at this. So it's asking us to classify the real numbers. It says which set of numbers in the set, and it gives me all those mumbo jumbo numbers like -10/3, pi, square root, or negative square root of 3, -1, 0, 2/5, 5/2, square root of 3, 5, and 101. So it asks me, hey, which numbers are natural numbers? Jay Patel, give me a natural number. Jay?
1.
1, very good. So 1 would go, oh, we don't have 1 on our list. We have -1. Do you mean 101?
Yeah.
All right, so 101 is a natural number. Are there any other natural numbers?
5.
5, perfect. All right, so those are my 2 natural numbers. What about my integers? Let's go with Justin. Justin, can you give me some integers here? There are 4 of them. Can you figure out all 4?
-1, 5, 101, and 0.
Perfect. All right, rational numbers. Laura, rational numbers. There are 1, 2, 3, 4, 5, 6, 7 of them. Can you give me all 7?
2/5,
2/5.
2/5, 5 twos or 5 halves,
Okay.
-10 thirds,
Just about halfway there.
5,
Keep going.
101, -1, and 0.
Perfect. That's easy, right?
Mhm.
The last one says irrational numbers. There are trace irrational numbers. Nick, can you give me all 3 of them?
Yeah. Pi,
1,
-√3
2,
and √3.
3. Easy enough? It's pretty easy. Sorry that it doesn't line up with A, B, C, and D. I'm just trying to write big enough so you guys can see. All right. All right, there's a set here. Why don't you guys take a second and try them on your own? And then apparently I'm told that I'm reaching my max limit of 20 minutes of instruction, so I have to stop even though I don't want to. So why don't you guys finish this up? I'll go over it, and then we'll see how you guys do logging into the WebAssign, and you can get started on that. All right, so you guys try this one. All right, I'm probably gonna get bored and start this in a couple minutes, maybe like a minute, because it's very sad with nobody in here, and it's just me in a room by myself, talking to myself. All right, yeah, I'm bored now. Don't you wait for me. You guys better be doing this on your own.
Wait, what about negative pi?
What's up?
What about negative pi?
Great question. I'll get to that one when I,
So in the irrational?
yeah.
Okay.
Was that Hannah who asked?
Yeah.
Instead of knowing your faces, I'm going to know the sound of your voice. All right, here you guys go.